Hi, I just want to talk about this problem a little bit. I feel like this problem is there's either a slight mistake or the problem is trying to be extremely sneaky, which actually isn't consistent with the rest of the worksheets. So I think that there's a slight mistake. Anyway, here's the mistake. When we're talking about congruency, we can equate the sides directly one to another. Now, if I were initially looking at this problem, you have the longest side on this triangle right here and matching up with the longest side of this triangle right here. So this thing will match up with that thing over there, and then you'll have something like x plus 5 equals 3x minus 4. Now, I can actually demonstrate that this is, the case by rotating this a little bit. Let's see, let's rotate this 180 degrees. All right, cool. So you can see that now I've just, rotated the triangle a little bit, and then I've made them to kind of line up with each other in the correct orientation, and that would be what they would look like. So when you solve this out, you end up getting like, let's see, we'll move x over there, and so we have 2x equals 9, and we have x is equal to 9 over 2. Now, that isn't what the answer key says. It says x equals 6. And a lot of students would ask me, well, how, in order to get that, I would have to have the 3x minus 4 equal to x plus 8. And then, of course, you would have 3x equals x plus 12, and so you have 2x equals 12, and you have x equals 6, and that would give you the correct answer. And my response to that is, well, technically they wrote the problem correctly. One of the cardinal sins that you would do in geometry is you should never trust a picture for face value. I mean, here's a prime example of it right here. Is look at the sides of this triangle over here. This side is x plus 8. It's supposed to be bigger than the x plus 5. I don't care what x is. X plus 8 is going to be bigger than x plus 5. So right off the bat, you can see that these sides this picture is not drawn to scale. And in that respect, and then some of you would say, okay, even though the picture is not drawn to scale, I can still match up the longest side with the longest side. And my answer is, no, you can't always do that. Let me rotate this guy back. Let's do this. Rotate him. All right. So let me go about it, by exactly how they defined the thing. And this might be too nitpicky, but this is the only way that I can see how this solution could conceivably be correct. So if we say they literally told us triangle ABC and DEF are congruent. So I'm going to draw a line between AB. So the way they're defining this triangle is they do AB first. So let's draw a line through that. And then over here, the first segment that they're quoting is DE. So we'll draw a line through that. And then the next segment that they're quoting is BC. So we'll draw a double line through that. And over here would be EF. So we'll draw a double line through that. And then it's cyclical, so we'll go back to CA. So we'll draw a triple line through that. And then over here is FD, and so we'll draw a triple line through that. And then according to how they defined it, if I were to redraw this second triangle in the correct orientation, so let me try rotating it a couple of times and seeing how okay, see how this thing doesn't work because the single line is on the left side, whereas the single line is on the right side over here. So I'm going to have to probably flip it horizontally. Now, if you ask anyone, they would say, oh, those pictures are not correctly oriented. And I would say, yeah, but never trust the picture. And if you don't trust the picture, and if you only go with how they define the triangles, then what you can say is, okay, well now x plus 8 is equal to 3x minus 4. That's a perfectly valid statement over here. And then your answer would be consistent with what the answer key gave. X equals 6. Now, here's the reason why I think it's a typo, is because that kind of trickery and sneakiness is not consistent with the rest of the worksheet. It didn't seem like this is a worksheet that's trying to teach you never to trust a picture. I think that all that happened here was in the original triangle. And let's rotate this guy back to one more time. Let's see. Oops. Draw right there, and then do one of these. I'm going to flip them horizontal, then rotate. There we go. Back in the original triangle, I think all the mistake was you should have put this thing here and this one here. Oh wait, you should put this one here and this one here. And if you switch those, the problem would be much more, I suppose, easier or consistent.